Hi everyone! Today we are going to learn how to simplify complex fractions. There are two methods in order to simplify complex fractions, and this first lesson is about method number one. We call it method number one. Now our learning target for this lesson is to be able to say I can simplify complex fractions using one of two methods, and to be able to say I can simplify complex fractions. So we want to simplify complex fractions to solve real-world problems. So a complex fraction is a fraction that contains, so it is a fraction that contains a fraction in its numerator or in its denominator, or in both the numerator and the denominator. A complex fraction can be simplified using two different methods, and this lesson is going to be all about method number one. Method number two will be in the next video. So method number one says, if necessary, simplify the numerator and the denominator by writing each as a single fraction. Then we're going to divide the numerator and the numerator by the denominator. So what this means is that a complex fraction, our goal is to take a complex fraction like we have in our warm-up, and we want to rewrite it so it's a fraction over a fraction, like A over B divided by C over D. So that's what this says. A over B divided by C over D. So this is supposed to look like the letter C. C over D. What this looks like is A over B, or what this really means is A over B divided by C over D. And whenever you divide fractions, we know that we always multiply by the reciprocal. So that's going to be A over B times D over C. And whenever you multiply fractions, we always multiply straight across. So this is going to be AD over BC. So that's what we're going to do for method number one. So my goal, what I have here in our warm-up are two different sections. One section is going to be for method one, and like I said, in the next video, we'll work with method number two. So here is method number one. For method number one, what I want to do is I need to work with each individual numerator and denominator. So what I mean by that is here is my big numerator and here is my big denominator. And I'm going to work with the numerator individually and the denominator individually. Let me go ahead and make this clearer. All right, so my denominator, so just only working with my numerator, I need to come up with a least common denominator. So I have a 2 and a 5, and 2 and 5 have nothing in common. So what that means that I'm going to do is I can multiply 2 times 5 to get a common denominator of 10. So I'm going to draw out my fraction bar, and I need a common denominator of 10. So that means I'm going to multiply 2 times 5, and whatever you do to the bottom, you have to do to the top. And I'm going to end up with 15 over 10. To 1/5, I need to change a 5 into a 10, so I'm going to multiply 5 times 2, and whatever you do to the bottom, you have to do to the top. 1 times 2 is 2, and 5 times 2 is 10. So now I have myself a common denominator. And now I'm going to write a little equal sign, and I'm not ready to talk about the denominator quite yet. I'm just going to turn that top fraction into its own fraction. So just a single fraction. 15 minus 2, that is 13, so we end up with 13/10. I'm going to stop right there and now work on just my denominator. So now my denominator, my big denominator, that is 5/6 minus 2/3. I know that 3 can go into 6 evenly, and that I need to come up with a common denominator, and my common denominator is going to be 6. Since 5/6 already has the denominator of 6, I'm just going to rewrite the first fraction as 5/6. In order to change a 3 into a 6, I need to multiply 3 by 2. And whatever you do to the bottom, you have to do to the top. So 3 times 2 equals 6. 2 times 2 equals 4. So now I'm going to combine 5 minus 4, and that's going to be 1. So now I have 13/10 over 1/6. So what that means is 13/10 divided by 1/6. And whenever you divide fractions, you multiply by the reciprocal of the second fraction. So I'm going to multiply by the reciprocal of 1/6, which is 6 over 1. So I'm going to take 13/10 and multiply it by 6 over 1. I know that 6 and 10 are both divisible by 2. So if I were to go 6 divided by 2, that's going to be 3. And 10 divided by 2, that's 5. And now multiplying 13 times 3, that is 39. And 5 times 1, that is 5. My answer is 39/5. I'm going to put a bunch of stars around this warm-up. And the reason why I'm going to put a bunch of stars around this warm-up is because this problem is not only going to be a problem on your test, but it's also going to be a problem that's going to be on your final exam. So in June, when you guys are taking your final and you're trying to figure out what problems you need to study, this is a problem that I absolutely want you to study for your final exam in June. All right, so now I'm going to skip down to letter A, and we're going to work with method number 1. I'm going to recommend strongly that you draw a line for separation between method 1 and method 2. And here we go. So our goal is to have a single fraction over a single fraction. That is the goal. So for method 1, your goal is to have a single fraction divided by a single fraction. It's always important to know what your goal is. So what's nice about letter A is that we already have our numerator as a single fraction. So I'm not going to look at it anymore. I'm now just going to focus on the denominator. And in my denominator, I need to come up with a least common denominator between x plus 4 and x, just like we did in the last lesson. So looking at I'm coming up with a least common denominator down here. I have an x and I have an x plus 4 that I'm going to put into parentheses, because anytime I see addition, I'm going to put parentheses automatically around it. So therefore, my least common denominator is going to be one of each term, or one of each factor represented. So I'm going to have an x and an x plus 4, and that's my LCD. So therefore, I need to change my denominator to be, and so far I have a 5 over x plus 4 in my numerator. I'm going to draw that out, and now I'm ready for my denominator. I need this denominator to be an x times an x plus 4, plus I need the other denominator to be an x times an x plus 4. So what do I need to multiply x plus 4 by to turn it into an x times an x plus 4? Well, I need an x, so I'm going to multiply the top and the bottom by x. 1 times x is x. And in the denominator, we always leave denominators in factored form. We always FOIL in the numerator. So now the 2 over x already has an x, and it needs an x plus 4. So I'm going to multiply the top and the bottom by x plus 4, and I'm going to put that into parentheses. I'm going to distribute in the numerator, and I end up with 2x plus 8. So now that I have a common denominator, I can combine my numerators, and I now will have, I'm going to write an equal sign, 5 over x plus 4, all over x plus 2x is 3x plus 8, all over x times x plus 4. Cool, I've just achieved my goal. My goal is to have a single fraction over a single fraction, and that's exactly what I have here. It's very important that you make your fraction bar big so that you know where your numerator is and where your denominator is. It's very important that you have that. So now I have 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. Whenever you divide fractions, we always multiply by the reciprocal of the second fraction. So that means that I'm going to end up with 5 over x plus 4, and I'm going to put that into parentheses, times the reciprocal, which is x times x plus 4, all over 3x plus 8. Anything that's the same on the top and the bottom, we eliminate, so the x plus 4s will go away, And our answer is going to be 5 times x in the numerator and 3x plus 8 in the denominator. And that is our answer. So now I'm going to leave method 2, letter A, outside, and now I'm going to flip the page and we're going to do 2 more examples. Those 2 examples are going to be letter D and letter E. So letter D, we're going to be working with method 1, and letter E, we're going to be working with method 1. We'll do B, C, and example 10 with example 2 in the next video. So looking at letter D, we have ourselves a fraction, a single fraction over a single fraction. So that's awesome. That's exactly the format that we want. So therefore, I'm just going to rewrite this as x squared minus x minus 6 all over x squared plus 4x. And I'm going to multiply it by the reciprocal of the second fraction. So that's going to be x over x plus 2. So at this point, it's very important for us to figure out what we want to eliminate. So that means that we're going to need to factor both the numerator and the denominator into different parentheses. So x squared minus x minus 6, I'm going to split apart the x squared into an x and an x, and ask myself what 2 numbers multiply to equal negative 6, but together add to equal negative 1. And that's going to be negative 3 and a positive 2. Then I'm going to ask myself what 2 numbers multiply to equal x, what does x squared and 4x have in common? And they both have in common an x, leaving x plus 4 inside of the parentheses. Then I'm going to write times x over x plus 2, and I'm going to put that x plus 2 in parentheses as well. Anything that's the same on the top and the bottom will get eliminated. So the x plus 2's will get eliminated, and so will the x's. Our leftovers is an x minus 3 in the numerator and an x plus 4 in the denominator. That is our answer. All right, let's go ahead and look at letter E, and then we'll be finished with today's lesson. For letter E, notice that we have negative exponents. Whenever we have negative exponents, that means that those exponents are not happy where they're located. So what we're going to do is we're going to rewrite them in a way that makes sense. So remember that we always work with our numerator and our denominators individually. So 4 minus k to the negative second power. What that means in reality is 4 minus 1 over k squared. That's what that numerator is going to be. All over. Down here we have 2k to the negative first minus k to the negative second. So what that means is I'm going to bring that k to the negative first down, so we have 2 over k minus k to the negative second is going to be 1 over k squared. So here I have a complex fraction. So now my goal is to change the numerator and the denominator to be single fractions. So I'm going to work with the numerator first. Technically, 4 is a 4 over 1. So I can rewrite that as 4 over 1. So between 1 and k squared, my least common denominator is going to be k squared. So I'm going to write a little equal sign with the fraction bar. And my goal is to change this, both denominators to be k squares. So fortunately, the second fraction already has a k squared as a denominator, so I don't need to adjust it. But this first fraction needs to have a denominator of k squared. So I'm going to multiply the top and the bottom by k squared over k squared. And so I end up with 4k squared over k squared minus 1 over k squared. And so that's going to equal 4k squared minus 1 over k squared. And that is my numerator. Now I'm ready for my denominator. What does k and k squared have in common? Well, since they both have in common a k, the largest degree wins. And the largest degree between k and k squared is k squared. So I need to change both of my denominators to be k squared. Fortunately, my second fraction already has a denominator of k squared, so I'm not going to change it. So I'm going to multiply just the first fraction by what it needs. it needs another k. So I'm going to multiply the top and the bottom by k. 2 times k is 2k, and k times k is k squared. Now that I have a common denominator, I'll combine the numerators to make this 2k minus 1 all over k squared. So now I have a single fraction over a single fraction, which is really nice. So that means I'm going to rewrite this as 4k squared minus 1 all over k squared. And this is going to be times the reciprocal of the second fraction, which is going to be k squared over 2k minus 1. So if you want to cancel out the k squares, that's fine. We end up with 4k squared minus 1 all over 2k minus 1. But we're really not done. And that's because the 4k squared minus 1 is actually a dot, a difference of 2 squares. And we need to factor that. So I'm going to factor 4k squared minus 1 into a 2k plus 1 times a 2k minus 1, and this is going to be all over 2k minus 1. Anything that's the same on the top and the bottom will get eliminated, so I'm going to eliminate the 2k minus 1s, and my answer is 2k plus 1. And that is the end of this lesson, and as well as working with method 1. When I see you in class next time, we are just going to be working on method 1. Then you guys will watch the video for method 2 that night after we've worked on method 1. And then I want you guys to decide which method makes the most sense to you. I can tell you that method 1 makes a lot of sense for a lot of students, but method 1 is a little bit more work than a method 2. So you'll see that in the supplemental videos. But in the meantime, if you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.